In previous videos, I talked about using the addition principle as well as the multiplication and division principles for solving inequalities. I also talked about what you need to do when you are multiplying or dividing by a negative number. And if you're not sure about that, I do have a video on it, so go back and look just to refresh yourself before you move on. This video is going to really focus on combining all the principles that we've been talking about, as well as kind of a little review of distributive property. And anyway, so let's get on with it. And really the ultimate goal here is to isolate the variable so that we can solve the inequality. We can come up with a value for that value. All right. In our first example, we have 8 minus 4x is greater than 9. Now, one other thing that just I want to mention before we continue here is for each of these problems, I'm going to graph my solution and then I'm going to check it. I'm going to choose one of the numbers from the solution, plug it back into the original inequality, for example this one, and then we're going to hopefully come up with a true inequality. If we don't, then obviously that's something, it's like a little red flag. You need to go back and look at your work again. Feel free to do these problems and then pause the video and then come back to follow along here. Okay, now like in previous work when we were solving for a variable, an unknown variable, what we would do is basically use the opposite of order of operations. And so, again, if you write PEMDAS, it's a good way to remember the order. Normally you would do multiply and divide before add and subtract. What's going on here is you have a number, you're taking away, so that's subtraction, and you're multiplying 4 times the number. And of course this 8 happens to be a positive number here. So if our goal is to isolate this x, we need to get rid of this number here, which is the positive 8, and then also this negative 4 we need to get rid of. So we're going to take care of this 8 first by subtracting or basically adding the opposite of positive 8. I'm going to go ahead and write it as subtract 8 from both sides, and that's going to cancel. We're left with negative 4x, and 9 minus 8, that's going to give me 1, and so we've got negative 4x is greater than 1. So in this case we did the add subtract first. Now we're going to take care of the multiply divide to again isolate that x. That's our ultimate goal. Now we've got negative 4 times x. Let's divide by negative 4. And we're going to do that to both sides because that's going to cancel out our numbers, and we're only left with the variable, which is what we want. And then of course 1 divided by negative 4 is going to be negative 1/4. Okay, now remember when we were multiplying and dividing by a negative number, we had to reverse the symbol. So we're going to go ahead and rewrite that as a less than instead of a greater than. Okay, so I'm going to sketch out a number line. And let's see, x is less than 1/4. So let's say this is 0, this is 1, this is 2, -1, -2, -3. Okay. So less than negative 1/4, I'm going to say it's probably around here. And because this is less than, I'm going to make an open circle, and x is less than, so I'm going to go to the left. Darken that line and the arrowhead also. And any of these numbers are possible solutions for this inequality. All right, now what we're going to do is we're going to choose a number less than -1/4. I'm going to go ahead and pick an easy one. I'm going to pick -1. And I'm going to plug it into this original equation here. So let me zoom out a little bit so we can see everything. So we're starting with 8 minus, and we've got the -4, and I'm going to choose -1 greater than 9. Okay, I'm going to use a little question mark there because we're going to see if this is actually true, if it's going to work. We're always going to multiply first, so we've got 8, a -4 times a -1 is a +4. And 8 plus 4 is 12, and sure enough, 12 is greater than 9, so this would be a true inequality. And so I feel confident that my, what I came up with here would be correct. Now, if you're not sure, if you think, well, now I don't really believe in this reversing business, choose a number that's, the other way. So if you didn't reverse it, you would have had x is greater than -1/4. Say you chose 1, and there's no harm in checking. So let's plug in a positive one. So 8 minus 4 times +1, is that greater than 9? Or excuse me, yeah, greater than 9, because the original one, it was greater than. So we're going to go -4 times 1 is -4. 8 times 4 is 4. Now, is 4 greater than 9? No, that's false. So that's just a reminder that when you are multiplying or dividing by a negative, you must reverse that symbol so that when you plug in one of the solutions, you're going to get a true inequality, like we did here in this first time. Okay, so don't do it that way. Okay, let's do another one in which we're combining principles, and this is a good one. This is where we're going to have the variable on both sides of the inequality. Let's say we have 2x minus 11 is less than or equal to 5x plus 4. Now, when we were just working with equal or equations with equal signs, and we had variables on both sides, we'd have to choose one to bring over. And so, and I want to avoid negatives because then I'm going to have to reverse the sign. So I'm going to move this 2x over here because this is a positive 2x. So I'm just going to subtract 2x from both sides. That, of course, is going to cancel, and I'm left with -11. It's less than or equal to, and that's going to give me 3x plus 4. Okay, now I want to get rid of this 4 business. I'm going to do the opposite of add positive. I'm going to add a negative, or I could just subtract the 4, subtract 4. Okay, now here we have -11 minus 4, and remember, if you write it like this, -11 minus 4, we could write it using the additive inverse, -11 plus -4. So really we're just adding the two negatives together. We're going to get -15 less than or equal to 3x. Now notice in this case, we've got 3 times a number, so the opposite of that, or the inverse, would be divide by 3. Notice this 3 is positive, so I'm not going to have to mess with reversing the sign, which is kind of nice. So we're going to divide by a positive 3. We're going to get -5 is less than or equal to x. Okay, now of course I like to graph first. And I'm just going to create a number line and throw on some numbers. Let's say this is -5, -6, -7, and then the opposite direction, we'll go like that. Okay, now because this is less than or equal to, it's going to be a closed circle on the -5. So I'm going to color that in. And x or -5 is less than, so you could write it, you could switch it around if this is confusing. You could write it as x is greater than or equal to -5. And so when I'm coloring in, notice the x is going to be larger, so I'm going to the right. And I'm going like that. Just a side note, the reason I know, I switched it in this case, notice that the large opening faces the x, it continues to face the x. So, I really didn't do any reversing of the symbols because I'm just flipping, I'm just doing the mirror image of this x. Anyway, I know some of you might be a little confused about what I just did there. All right, now we're going to check. Let's check. Let's pick a number. Let's see, we've got, we could do -4. So we're going to start off with our original, let me zoom out again. We're going to start off with our original problem here. Okay, so we'll go 2 times -4 minus 11. Is that in fact less than or equal to 5 times -4 plus 4? And if we do order of operations, we're going to multiply first. That's -8 minus 11, which is going to be -19. And that's going to give us -20 plus 4, so that's going to be -16. And is -19 less than or greater than -16? Yes. Even though 19 is a larger number, remember that negative means it's further away from 0, it's a smaller number, and so this is true. Okay, I have one more fun inequality in which we're combining principles. And this one's going to utilize distributive property. So 3 times the quantity of x minus 8 minus 2 is less than or equal to 4 minus 5 times the quantity of x minus 2. All right, looks like we have distributive property on both sides. So, distributive property is great for getting rid of those parentheses, and then of course you can combine like terms if you can, and then move things around. So we're going to do that. 3 times x is 3x. 3 times -8 is positive 24 minus 2. And we've got the 4. -5 times x is -5x. -5 times -2 is plus 10. All right, moving on, we can combine this 24 and negative or minus 2 is going to be, oh wait, I messed up here. This is going to be a negative. 3 times -8 is -24. Hopefully you were scratching your head when I wrote that plus sign. If not, that's okay, we caught it. So now again we've got 3x, -24 minus 2. That's really -24 plus -2, which is -26. And 4 plus 10 is 14 minus 5x. All right, moving on. Let's see. Well, if we move this over by adding 5x, we're not gonna. If we were to do it the other way, we would have a negative, and then we would have to switch. So I'm going to go ahead and add 5x. Sometimes you don't have a choice. You got to do what you have to do. But if you can avoid dealing with that negative, you know, just makes it a little easier. 3 plus 5 is 8, so we've got 8x minus 26 less than or equal to 14. Now I want to get rid of this part here. So you always want to add, subtract before multiply, divide. It's opposite of order of operations when you're solving for a variable. So we're going to add the opposite, or just add 26, both sides. Oops, 26. 8x, this is going to cancel. And then 14 plus 26 is 40. Okay, notice this is positive 8 times x, so we're just going to divide by the 8. And we're left with x is less than or equal to 5. Now, I want a graph so I can figure out a number to plug in just to check my work. And let me just create some lines here. And I'm going to say this is 5, 6, 7, 4, and 3. So a range of numbers is good. Now, this is less than or equal to, so we're going to have a closed dot, or a closed circle. X is less than or equal to, so I'm going to go to the left toward the negative. Now I want to check. Okay, it's good to check your work. And let's zoom out to look at the original problem. I'll just move my paper. Let's say we pick 4. Okay, that's one less than 5. And I'm just going to rewrite, and everywhere I see an x, I'm going to write in a 4. So 3 times the quantity of 4 minus 8 minus 2. Is that less than or equal to 4 minus 5 times the quantity of 4 minus 2? Okay, now we're going to do parentheses first. So 3 times 4 minus 8 is negative 4 minus 2, and then we'll continue over here. So we got 4 minus 5. 4 minus 2 is 2, positive 2. Now we're going to multiply before we subtract. So 3 times negative 4 is negative 12 minus 2. That's the same thing as negative 12 plus negative 2, which is negative 14. And we've got 4 minus 10. 4 minus 10 is negative 6. Okay, so is negative 14 less than or equal to negative 6? Yes, it is. Negative 14 is further away from 0. This one's closer to 0. So this is the larger number. And so this is a true inequality. Now this last one, of course, was really combined a lot of different skills that we've been working on over the last several weeks. And, we're just going to keep practicing in class. So bring your questions and we'll do more problems.